Welcome to Math Foundations. So this video is just kind of a welcome to give an overview of the class and what we're doing and what you're expected to do and some other things like that. So I'm going to go through, I'm going to introduce you, explain a little more about what the class is. I'm going to introduce myself. I won't take too long. We'll talk about the textbook, which is free, by the way. We'll talk about what is inquiry-based learning, because this class is based on that. And then grading and summary. Now, introduction, this class is about writing and reading mathematical proofs. It's a very technical writing heavy course. You are going to actually have to write technically. This is not just something where you can just slap it together or so forth. You're going to have to do edits and drafts and submit a final version. I would encourage you to learn how to write in LaTeX or else get really comfortable with typing stuff in Microsoft's compiler, because you're going to have to do a lot of mathematical symbols and other things like that. And I'll just tell you right now, Microsoft sucks for that purpose, or my language. We're also going to think very abstractly in this class. So you're not going to just be about calculations. That class has very little calculations. It's almost entirely about using logic and writing and explaining why something is true or why something is not true. Sometimes finding counterexamples and all things like that. We'll get into this more. So me, if you don't know me, well, I know all of you, but if you don't know me, I'm Dr. Bailey. I am an assistant professor of math. I'm also the math coordinator. I have my PhD in math from Utah State. I also have my master's from them and my master's in education from the University of Oregon. Um, my personal research is in graph theory and combinatorics. Also in math education, I've done a lot of research in perception and how that affects. So I'm going to talk about a different strategy for how we're teaching this class, which actually, by the way, is highly effective, but it's going to require a little bit different approach. Side note, I do enjoy powerlifting just for the fun of it. So this class, the prerequisite as it currently stands is Calc 2 with a C or better. Truthfully, we tried changing this a couple years ago, and for some reason, it just never got changed in the books to actually be discrete math, because we're going to use discrete math. We're going to use our ability to write proofs. Yes, we are writing lots of proofs. So everything you learned in discrete about writing proofs, this is where we're going to use it. All right. So our textbook was Introduction to Proof via Inquiry-Based Learning by Dan Ernst. This is a free textbook. I posted a version of it inside of Canvas. Our syllabus has a link to a website. It is 100% free. You're welcome. Now, it's free, which means it's imperfect. Now, and also the title tells us something. It's about inquiry-based learning. So what is inquiry-based learning? To quote the book yourself, it literally says, your author wrote, inquiry-based learning is a student-centered method of teaching mathematics that engages students in sense-making activities. So students are given tasks require them to solve problems, conjecture, experiment, explore, create, communicate. Rather than showing facts or a clear, smooth path to a solution, the instructor guides and mentors students via a well-crafted problems through an adventure in mathematical discovery. This means you will be doing it, not just watching a video and then trying to copy me. More, I'm going to give you hints. You're going to attempt it. And my job is actually to be stepping in to give you the correction over time. So inquiry-based learning, you need to be asking the questions. These questions aren't just tell me how to do it. It's like, well, okay, what worked, what didn't work? Why is that not correct? This process is actually the best way, in my opinion, to learn proofs. When I first learned proofs myself, I'll just tell you, I did it based on Euclid's Elements, which all of you know is a geometry book. It's the basis of Euclidean geometry. Well, the problem is I was, for the most part, and we were just proving the book entirely, just following along and copying what my professor was doing. I learned some cool things about using a straight edge and a compass, and what are different things like axioms and so forth. But I didn't really understand how to prove proofs. And so when I took later classes that were very theoretical and abstract, I did not have the skills. I didn't understand the different methods of, for instance, a proof by contradiction, or really understood how to do some things like a direct proof even. I could do some direct proofs, but mostly proofs by construction. So there's a lot of things that I kind of messed up on and had then learned later on. I don't want you to have to do that. This class, we're going to have it. So you're going to mess up. Don't be afraid of that. And we'll get into this more. This is why we have discussion boards. Is there an opportunity for you to post? This is how I think I would prove it. And then someone else can respond. So for this to work, I'm going to make a note. You shouldn't be just Googling and slapping in what the internet tells you. While that might help you get through stuff quickly, I'm going to warn you right now, we are going to have some quizzes that are going to be proctored so that you're just going to get yourself in a bad situation if that's what you're focusing on. Speaking of grading, let's just talk about it. There are 3 areas of grading for this class: homework, discussion boards, and grading. So the homework, it's going to be about once a week. It's going to be due by Saturday up in Canvas. You need to upload a PDF including all of your work and solutions. And this should be a final draft. Please don't be giving me something that's still a edit or draft one, lots of crosses out and so forth. You need to, this part of this class is essentially mathematical technical writing. You need to be ready to write stuff up, to give me a final version of it that's nice and clean. I'm going to grade you on not just whether or not your answer is correct as a valid method, but is it fluent? Are you using the correct terminology and notation? Is it readable? And when I'm beating that, I'm not just talking about handwriting. I'm talking about are there honestly grammatical errors? And believe it or not, I was graded on grammatical errors. So it's part of our process because we actually use writing, and it's used in all over the places. Now, to prepare you each week, we're going to have at least 2 discussion boards. These are in essence our class. So inquiry-based learning, the way inquiry-based learning normally works in a live classroom is I give you problems, you come to class, and you present them literally to each other on the board. And while you're doing that, I ask questions or other things to guide you, to correct you as you make mistakes. Well, we can't do synchronous meeting because this class is online. We're trying this differently. So instead, what I'm going to have you do is post in the discussion boards either a video of yourself working on it or something of you working on it. Now, I'm going to tell you right now, the edits are turned off on the discussion board. So once you post something, you can't delete it or edit it. And that is okay. It's meant for you to post and then work your way through. You also will not be able to see anyone else's work until you post yours. So you need to jump in. Don't be afraid to make mistakes and really give these things an effort. You'll be graded predominantly on participation for your discussion boards, but you need to read the directions and try to go through. I really do think you should use like a video. And what you can simply do, if any of you don't have this, is you have it on paper, like write it out all nice and stuff. And then you can even like stick your phone over the top of it and record it, or have someone else record it. You could write it on a whiteboard and have someone record it for you. This is a great opportunity to engage in the class. After that, usually every week, we are going to have a definition or theorem quiz. This will be using lockdown browser in Canvas, which will lock your browser. You can't access other stuff, and have a video. It'll be closed book, closed note, closed neighbor, etc. It's going to be short. It's only going to be a couple questions. It's like state a key theorem or definition. And it also may include some very short, brief proofs, because I do want to see some of your proof techniques when you don't have access to other resources, so I can see really yours. These, if I give you these, they will be based on the homework or on the discussion boards. Predominantly, our proofs are going to be things you have time to work on. The reason being because that's how they work. Our brains need time to ponder and work on puzzle these things over and over and over again to really get them right. So again, every week, if I was you, I would plan time to participate. Remember, this is a 3-credit class. So even though it's online, the expectations have not changed. You're still expected to put in 3 to 4 hours per credit, which means you're putting in 9 to 12 hours a week on this class. I don't recommend doing that on one day a week. It won't work for the discussion boards because they're due throughout the week, and like you have to respond and then come back and participate, because you're not just posting your response. You then need to be reacting to other people's. So you can post like, this is how I did this problem on discussion boards, and then this is how Oh, I saw you did it this way. I did it this way. Why'd you choose that way? Like, you ask questions. This is not just nice. If you just do nice or cool, good job, it's not going to fly. Okay. Y'all need it. Y'all need to give a little more. All right. Let's talk a little more about this, though, about how it's going to break down. So we're actually going to grade each of these. Your homework is graded on pass fail. So when you turn your homework, it's either 100% correct or it's not. You could have a valid answer, but it's not fluid or readable, in which case I'm sending it back to you. So, and you get to submit it. Every time I give it back to you, you have up to 1 week to correct it and send it back. And you get 2 corrections per homework. You need to pass 90% of your homework. Really, what that means is you should be making a very good effort to pass it the first time. Um, I'm not going to accept late homework. So if you didn't submit it during the first week, I'm not going to count it. But you need to submit something. So what's worst case scenario? You submit something that's total junk and I throw it right back at you and you get a second chance. But you need to submit it. Your discussion boards, you need to get at, you're going to be graded each week and you're just going to get a percentage. So each of these categories, notice I have you pass at least 90% of all the homeworks. You get a discussion board average of 90% or quiz average of 85% for A. However, to get an A, I'm allowing you to have one of these categories be less and to be in the B category. So let's say, for instance, you had a 95% on your discussion boards, you got a 90% on your quizzes, but your weekly homework was only like an 85%. That is still a B. However, I'm going to highlight to help this visualize this a little better. Suppose for a second that you got oh, I don't like that color. You got at least 95%. You got 90% on your discussion boards and another 90% on your quizzes, but you really didn't do much of your homework and you were like 75%. The truth is, notice this last one is down here in the C category. That actually means the highest grade that you can get is a B. So this is partly dealing with what is your low and what is your high. So I'm allowing you to have a little bit of wiggle room with one of these categories, but only one of the categories. So if, for instance, let me give you a different example. Let's do a different one. Suppose that I got really good on discussion boards, but your homework and your quizzes fell in the B range. Well, because even though your lowest one's in B, your second lowest one is also in the B range. That would put you at a B overall. Now, if I did it, one of them's in A range, one of them's in B range, one of them's in C range, you still end up in the B range. So this allows some wiggle room here. You can play around with them, kind of get this. And I want you to ask questions if you don't understand what's going on here with this. All right, couple final things I just want to wrap up with, and that is a recommendation that you make it regular throughout the week. I know this is online. Online's easy to forget about, but make a schedule and say, hey, I'm going to engage on this on Mondays and Wednesdays and Fridays. I'm going to put in like 3 hours each of those days. If you make it time, it will work better and it'll seem easier. Also, in order to do the deep thinking we need to do for abstraction, you need quiet time. That means you're not watching anything. You can listen to music. My PhD advisor personally liked to use hard, heavy metal. I mean, seriously, you walk in his office and it was kind of like, how are you thinking of this? But that's how he thought. He worked great in that condition. If you like music, you go ahead, but I would turn off your phone. I'd put your phone away from you for a little bit. Take a break. You need to have focused time to really do this. When I'm really working on proofs like this, I turn off stuff. I close my door. I get by myself, and that's how it works. I also want you to ask questions. I was going to use Slack. I ran into a recent problem with that. Instead, I'm trying to find an alternate issue with that, problem with that, but just communicate with me, talk with me, ask questions on the discussion boards. When people do stuff like, hey, how'd you come up with that? Like, these are really good questions to talk, and I want you to interact. That's how we're going to learn. You all are math majors. That's why you're taking the class. And to be a math major means you have to be inquisitive. You have to really want to know stuff. Now, also, finally, Just last note, don't be afraid to fail. Don't be afraid of trying something and it doesn't work. We all do that as mathematicians. I've been wrong so many times I can't tell you. So I'm excited for you. I hope you have a great class, and I know it's going to be a good semester. Feel free to email me anytime with questions, and good luck.